futurologist John, Dr. Salman Hameed, Mr. Universe, head of Kainat Studios. We are at your kitchen table in Amherst, and we're going to talk astronomy again, but you're also a big award show guy, so you watched the Grammys last night. What was your take on the Grammys?
I think the performances were amazing.
Yeah.
And I mean, I thought it was a nice show, and also with the LA fires, they were raising money for that, so I thought that was really good. But I was just blown away by the performances of the new artists.
Chappell Roan, Sabrina Carpenter.
Yeah, and Benson Boone.
Doing a lot of flips.
Yeah, and I was like, hey, that's how I usually do, prepare for having a conversation with you before that.
Do a couple flips.
That couple of flips.
I'm trying to learn. I'm pretty sure I could learn how to do a backflip at this point. I love that Beyonce won the album of the year finally. It was probably a makeup album of the year since they didn't give it to her for Lemonade, but whatever, I'll take it.
And Janelle Monáe.
Oh my God, doing Michael
Jackson. That was really cool.
That was so cool. Shakira looks like she hasn't aged in a day.
Yeah, and that was great to see our kids over there. That was really cool.
Right. And then very quickly, you're a board member of Amherst Cinema. Spent yesterday watching Wages of Fear. Have you ever seen that movie?
I have not, and I'm
1953 French movie about driving trucks filled with nitroglycerin. If you've ever seen the movie Sorcerer, which came out in the 70s, Roy Scheider, it definitely borrows heavily from this 1953 movie. So excellent, so good, such a fun time, packed house.
And I think there is one more showing.
There is.
I think on Wednesday or something like that. But do check. Yes.
4K restoration, gorgeous, crazy movie, super stressful and amazing. But we're here to talk about astronomy and potential signs of life on an asteroid.
No. And potentially no.
Okay.
No, so this is we talked a while back maybe about this asteroid return mission. So there was this NASA mission that went to an asteroid Bennu and got the samples, and brought them back. So this mission got there. I think it returned in 2023, and then it was in this sort of you can think of nothing more sacred than those samples, because those have been brought from the asteroid, and so they were in this chamber, and it took them a while to actually extract from them, and then those were distributed across some labs in different places, including actually to some exchange of samples to Japan, because Japan had its own mission Hayabusa 2. They brought in samples from another asteroid, Ryugu, and so some samples from Ryugu came to the US, to NASA, and some of the samples of NASA went actually to the Japanese scientists of JAXA, their space agency. So here is the reason why you want to bring samples back, because rocks from space, meteoroids, they do hit the Earth. And some of them, if you can find them quickly, those are great samples. And in fact, that's how we knew that asteroids have building blocks of life, or some of them have. And so there was always an interesting element to how did life start here, where did these elements came from. And so meteoroids offered those clues.
But maybe ancient alien life was on a meteor, hit the Earth, and then seeded this planet with the life as we know it now.
There is an idea regarding that. It's called panspermia. But we don't have evidence for that. And when meteoroids fall naturally, directly from space to the Earth, if a big one comes in, then nobody's here alive, to analyze them, like, for example, the dinosaurs. Mm-hmm. So that was a much bigger one, comet probably, or a big asteroid. But the smaller ones, those are really useful for us. But even then, the asteroid, or meteoroid, has gone through our atmosphere where it heats up, and oftentimes if they burn up in the atmosphere, you see a shooting star, or sort of but even if it hits to the ground and we try to get them quickly, the Earth microbes are pretty quick in contaminating it. Mm-hmm. And oftentimes people try, so for example, in Antarctica or in frozen lakes in Canada, people have tried to find these meteoroids quickly, but still those are not pure. This is the reason why going to an asteroid, what the NASA mission OSIRIS-REx did to asteroid Bennu, and it brought those samples back and put it in a in a container which was likely not contaminated. So that's what they did, and the first results have started to come out. And what it tells you, Bennu is a small asteroid about 2,000 feet across, and the samples tell us that, in fact, it has amino acids. So now, we knew that amino acids that life uses in our cells, they actually are used to make proteins and things like that, and our life uses 20 types of amino acids.
All of which I'm taking as supplements now that I'm old. I feel like all I do is like my job to eat protein and amino acids.
And so the question was, I mean, of course, the combination of amino acids available is much bigger, but our life uses 20 amino acids. And it turns out that in this sample that came back as part of the OSIRIS-REx mission, NASA mission, to the asteroid Bennu, that it found about 16,000 types of organic molecules, which included 16 of those 20 amino acids. So those amino acids are already there. And not just that, if you think about the molecule of life, the DNA, which has those nucleic acids like A, T, C, G, and also there's RNA uses a different one, uracil with the U. Well, this sample has all of those nucleic bases there. So you have proteins, you have the elements that make up the DNA, you also have that. And so the likelihood, that these materials were brought, especially in the early history of the solar system, what it tells you is that these molecules were available in the solar system. And it looks like an abundance, because here we go to an asteroid, we bring back samples, and those are already there.
Like a small sample of one random asteroid that just was easy enough for NASA to get to and bring a sample back from, and already all of the pieces of the jigsaw puzzle to put life together, not all necessarily, but so many are there. And the only thing missing right now is one solved puzzle of even one molecule or one atom of actual organic life.
Right, and I think we're going to get there in the sense that people are trying to figure out how did it actually started, but that is a big mystery. But I would caution against thinking, oh, that's a miracle. No, actually, if we know that there are all of these raw materials available, and if they could have some time, if they could have the right conditions, you can imagine actually becoming life. And of course, there is a whole conversation about what is the real definition of life. Nevertheless, you can imagine going from this kind of chemistry to biology because of all the pieces that are here. Now, one of the things I should mention that in the papers that have come out regarding that, just last week in Nature, there were a couple of papers regarding that. What they talk about is also the origins of the asteroid Bennu. So, which I found really fascinating because they trace it back. This is a much smaller asteroid, but they trace that it actually was probably a part of a 60-mile big asteroid, and it was actually formed beyond the orbit of Jupiter. So this was the conditions where it formed, and then because of the gravitational push and pull of Jupiter, it was flung inside, probably between the orbit of Earth and Mars, where due to an impact, it actually got shattered, and then some of the pieces came together to form this rubble asteroid Bennu, which was much smaller in size. So first of all, to me, that is kind of really cool that you can actually get sort of like samples from this asteroid, and you can actually figure out its history, that where it formed, and it did not form in the nearer part of the solar system, but in fact further away. Second thing is they also found some of the molecules in Bennu that it looked like that had spent a lot of time in a salty brine. And that is, again, one of those things that might be useful for building up these molecules that might eventually lead to life, although not in this particular case, because they think that probably it was heated, there was radioactive materials that was in the solar system earlier on, and this was a smaller asteroid, about 60 miles or so, and they think that radioactive heating from radioactive elements actually kept it a little bit warm, and also kept it places in cracks and crevices in the asteroid, had this salty brine for a few million years.
So like water, actual water, or?
And we Monty, we talked about this asteroid Ceres, which is sort of like, a larger, it's a dwarf planet now. Now we talk about dwarf planets in the asteroid belt. It had some shiny objects that the spacecraft that actually went past it actually saw something, and people were figuring it out. What is reflecting off of it? And it also has a salty brine in it. So it is this slushy water in there. So we know asteroids contain that. We know that those are the conditions that can lead to complex molecules that can potentially lead to life. Now, in this particular case of Bennu, or its predecessor, the larger asteroid, there probably wasn't enough time to have formed actual life, because a few million years probably was in these conditions where the heat lasted. But you can imagine other places like Ceres, which is a much bigger asteroid or a dwarf planet, that you have those building blocks, you have this salty brine, you have this for a few billion years, and maybe you have conditions to form a more maybe a primitive life or things like that. So those are all the things that are coming from just this sample. And we talk about, that on Earth, of course, you have a lot more time, especially earlier on, where you can how these molecules can lead to the origins of life. I think you can imagine that happening.
And really, we don't know what starts all of this stuff into gear. So many of the pieces are there. What is that one missing piece that then turns it over and begins to form it into life? Still something we don't know yet.
And also, I don't know how to think about it, that, there is this one particular step.
Right.
Rather, more likely than not, those are like a lot of these half steps. There is this continuation, and it starts to replicate. That is the key component to that, that at some point, whatever molecule that is, it figures out how to keep information and actually replicate itself. Perhaps, people talk about RNA as one of the ways to go, that to form a DNA. So we don't know the exact steps, but we can imagine half steps where it might go from chemistry to biology. Now, in this particular case, I should also mention one reason why we know there is no life on this sample. One is that on Earth, all of the amino acids that life uses are one-handed, like left-handed, for example. And it's just the way the structure of the amino acids come in. And that is a big mystery. So when we talk about the origins of life, one of the mysteries is, why does life only uses one-sided, or left-handed amino acid?
What do you mean left-handed?
It's the structure of the amino acids. It has, one side has bonds that are more than on the other side.
Okay.
So there are, in general, in the universe, you find left-handed and right-handed, as you would expect. Some of them are bonded in one particular way, and some of them are bonded in the other particular way, and those are randomly distributed. But all of life uses just one side of it.
I never knew this.
And so we don't know why. Some people think that it may lead to, for example, efficiency in terms of replication, or in terms of other processes, metabolism and things like that. But we don't know. Now, the samples, as far as I know, on this Bennu, they are not preferentially left-handed. They are both random.
Are you just using left-handed for fun, or is this how scientists really refer to it?
That's exactly how scientists actually use this, left-handed or right-handed.
I love that. And I love that left-handed is what defines life, considering how oppressed left-handed people have been over the years.
Well, it's called chirality, meaning to say, that you can have, it's with crystals, it's with other molecules as well. It just describes how the molecule is structured. So I don't, and I think it's left-handed. I'm an astronomer, so... Right. I can be butchering here biology, but as far as I remember, it was left-handed, and I'm not sure, being a right-handed myself, that there is anything unique about left-handed people.
They get their own special scissors.
Well, that is correct, and probably they cut it in their own special way as well, which is crooked.
Before we go away from asteroids, we've talked about Bennu and the return sample mission. There is an asteroid that is en route to us. Do we need to be worried as citizens of planet Earth?
No, first of all, but it is correct that an asteroid that was discovered right after Christmas, actually, of last year, I think December 27th, its name is Asteroid 2024Y4. And it has about 1% chance of hitting the Earth in December of 2032. Now, it is about, we don't know its exact size, but it's about 130 to 330 foot, feet wide asteroid.
Okay, feet, so not
Feet.
miles.
No. That would be a much serious problem. No, feet. And I mean, this is not something that will destroy a civilization, but it is big enough to potentially impact, for example, if it hits on a city.
Yeah.
So that, and I think it can do that. Comparison comes in with the famous Tunguska event that happened in 1908 in Siberia, where it exploded actually right above, right before hitting, right above the surface, and it actually destroyed about 800 square miles of the area around it with fires and things like that. So there is a threat to it, but of course, astronomers actually are going to look back at it. These type of threats have seen before as well, but then they recalculate the orbits. Once you have more information, you can, in fact, this asteroid is going to make a closer pass in 2028. So astronomers will get a better idea in terms of what the exact orbit is. And so we will know. Now, 1%, on the one hand, it looks like, hey, that's not that much. But from the perspective of this size of an object, which can potentially be a potentially city-destroying asteroid, it is serious enough to keep an eye on that. And so this is exactly what astronomers are doing. There is a scale which is how to evaluate these threats. It's called the Torino scale, which looks at the threat of hitting the Earth and the kind of damage it's going to do. So the scale goes from 0 to 10. 0 is like, hey, there is no chance, and 10 is like, okay, this is going to destroy entire humanity, right? So you can think about in that scale. This is around 3.
Whoa.
And
that's higher than I want that number to be.
Right, and that's the reason why people are talking about it. There has only once been one asteroid for briefly that went to 4. But otherwise, this is actually...
And then Bruce Willis took care of it.
That is right. Oh, and again, what I mean by that is when the orbit was recalculated or with more observations, it turns out, no, it wasn't actually that big of a threat. But this is the highest one so far. I wouldn't worry about it at all. I would rather more worry about, because this is a NASA-run telescope that discovered it in Chile. The stuff that we are talking about, Bennu, that is also a NASA mission. Those are all funded by the federal government. And so these eyes on these asteroids, what to do about those things, those are also NASA funded. And so what I would more worry about it is if its funding gets cut, if federal funds get frozen for these grants for people who are actually looking at these things and they cannot publish it. So here is one tiny thing I should mention, that if you are funded by federal, if you have federal funds, then you do open and research. Research has to be publicly accessible because you are being funded by public money. And so you make sure that it's out there. If, for example, instead of funding NASA, you go like, hey, here is a private company, let's call it Space
Twitter.
Space Twitter, right? Or let's call it Space Y. Okay? And it says, even though the infrastructure is funded by the public, but you go like, but the results and stuff like that, you handle that. They don't have an obligation to make things public. So I think that your question, should you go to sleep fine? Yes, from the perspective of the danger of the asteroid. No, if you are thinking about the future of publicly funded research.
Makes me feel bad that I put a lawn sign out during this year's campaign that said Giant Asteroid 2024, because that might be exactly what we get.
Well, yes, although it will really start in 25, and the trajectory is, we are still calculating, but this is more coming closer than farther away.